So this is Sam again. So let's continue the problem. I actually did the remaining steps so I can save some time and explain them to you guys. So now just to go back a little bit and see what we're doing here, make sure that we're all on track. What we want to do is be able to calculate the rate of change at any point on the function that is a nonlinear function. So this is x squared, a quadratic function, and I want to be able to, let's say I pick a point right here. I would like to be able, if I draw a tangent line, and a tangent as opposed to a secant is when the 2 points have approached each other to a degree that delta x, the distance in x, has become 0, okay? Has approached 0 indefinitely. This is the concept of the limit right here. So at this point, what is the rate of change of the function? Obviously at this point the rate of change would be lower than the rate of change at this point, right? Let's say here it would be a lot steeper. Here it would be less steep, and so on. So this is what we're doing here. The definition of the derivative continued on the left side. What I have done previously, we saw that x1 minus x1 have cancelled out, and after that the function of x1 plus delta x, remember that f of x is what? It's x squared. Okay, so if we add delta x to x, instead of having only x squared, we're going to have x plus delta x squared minus y1. What is the value y of the function? Y is the value of the function at the first point when there was no delta x added yet. So it's only x squared at this point. So we have this binomial squared minus x squared divided by delta x. The following step is we expand this binomial to the power 2, and we have x squared plus 2x delta x plus delta x squared, and finally subtract x squared. Okay, now just a recap. This is x squared plus, when you have a binomial, you do, after that you do 2 times the first term times the second term. So that's why I have 2 times x times delta x, and finally plus delta x squared. This is what I have here. And then subtracting x squared at the end, which is this one here, and we cancel out these x squared, and the final step, obviously we don't forget the denominator, which is delta x. Final step is factoring out the delta x. I have delta x here and I have it here squared as well, so what I'm going to do is factor it out. Delta x times what's remaining, well, 2x, because 2x times delta x will give us 2x delta x, plus we factored out delta x once from this term, so delta x times delta x would give delta x squared, and so we have delta x times parentheses 2x plus delta x over delta x. Now obviously this delta x and this one will cancel out, okay, and what we have remaining is 2x plus delta x. And as delta x approaches 0, what happens? Well, it's going to be obviously 0, so we don't care about it anymore. And thus the limit of delta x approaching 0 of the function x squared is 2x. And this is the derivative. Another way of writing a derivative is d dx, okay, of x squared. So the derivative of the function x squared is 2x. That was the first problem to introduce the derivative. Thank you for watching.